Good morning, students. Today we are going to a new topic, two-phase simplex method. Here, apart from the previous class, we have discussed about the graphical method and the simplex method. Why we need to go for the two-phase simplex method? Here, in any linear programming problems, we have to see the constraints which are having the signs greater than or equal, less than or equal, and equal to sign. So if it is the case of these, we need to introduce some new type of variables called artificial variables and some slack variables or surplus variables. By the introduction of these artificial variables, which is to get some basic feasible solution so that the simplex procedure may be used as usual until the optimal solution is obtained. And the artificial variable can be eliminated from simplex table and then it becomes zero, that is non-basic solution. So that means in the two-phase simplex method, we follow some technique called phase 1 and phase 2. In the phase 1, we will take the artificial variables since the constraints having greater than or equal to symbol and equal to signs. In that case, by introduction of artificial variables and in the phase 1, we remove the artificial variables or equate it to 0, then we have to process to the second phase. So by eliminating the artificial variable in the phase 1 of the solution, and then phase 2, which is used for getting the optimal solution. So the solution for linear programming is completed in two phases. So that this method is known as a two-phase simplex method. So that we will see where the artificial variables will be comes to the picture and the slack variables are surplus variables. Simply, what is the difference between the simplex and the two-phase simplex means? The simplex method is only applicable where the constraints having only less than or equal to signs. Apart from this less than or equal to sign, if it is having another type of sign, that means equal to or greater than or equal to signs, we may go for the two-phase simplex method. That is only the difference. So here for the explanation of these, we may take an example for easy understanding. And at the end of this first stage, there will be no artificial variables in the basic solution. Then only the solution will be exist for the given problem. And at the same time, the objective function in the phase 2 will be used for the original or given in the problem. So, and it was introduced in the final table of phase 1 and the objective function is optimized. So let us take it into the problem. Now coming to the simple problem for the explanation of two-phase simplex method. Try to note down the problem. Solve the following LPP by two-phase simplex method, and the maximized z is equals to 4x plus 3y subjected to 2x plus 3y less than or equal to 6 and 3x plus 1y greater than or equal to 3, and both x and y are all greater than or equal to 0. Suppose let us consider so it is easier to find whether the problem was to be solved in two-phase or simplex without knowing the method of application. That is, here in the constraint, we are having only less than or equal to, only less than or equal to in all the constraints, then we may use simplex method. So other than the constraints having less than or equal to symbol. See here in the first constraint, we are having less than or equal to symbol, but in the second constraint, we are having greater than or equal to symbol. So this method is not applicable to solve in the simplex method. So we may go for two-phase simplex method or graphical method also, this will be applicable. For simplex method, we have to see the constraints having only less than or equal to symbol. Okay, then what we will discuss is in the first stage. So two-phase simplex method means we have to do two phases. So in the phase one, construct. So straight away we can write it. Construct an auxiliary LPP by assigning a cost of 0. Assigning a cost of 0 to what? All the variables. Assigning a cost of 0 to all the variables and -1 to the artificial variable. Subjected to the given set of constraints. So that means what? This is the actual LPP, but we have to take some imaginary or auxiliary LPP by assigning the 0 to all the variables. All the variables means for x, y, what are the slack variables or surplus variables, but -1 for the artificial variable. When the artificial variable will be comes to the picture means for greater than or equal to constraint. This is a very important point. For greater than or equal to constraint, we need to subtract slack variable and add artificial variable, and at the same time for less than or equal to constraints add slack variable only, and for greater than or equal to type constraint add artificial variable only. See here what is the main difference means, as you know that for what are the constraints we are having, maximize z star. Y means maximize z is the original objective function, but we are taking here is auxiliary. So auxiliary means imaginary. So imaginary we will write it here. Before that, firstly constraint y and 3x plus 1y. Finally, we need to equate it to 6, or finally we need to equate it to 3. So less than means what? What are the things we need to substitute? For less than, only slack variables will be added. Okay, this already we framed at the simplex method also. So we are constructing only slack variable. That means the left hand side is less than right hand side. So we need to equate it, means some add some slack variable. And at the same time, LHS is greater than RHS. So we need to subtract something. So subtract means not to be same variable. So we are writing another variable plus add artificial variable. So this is the constraints, newly constrained equation. Then corresponding to that, what is the LPP? Auxiliary LPP will be for all the constraints. What is the thing? 0 x plus 0 y plus what are the variables we are having? S1, S2 plus what is the auxiliary the artificial variable will having only -1. So -1 a1. The coefficients of all the variables will be 0 and the artificial variable will be having -1. This is the auxiliary LPP to solve the phase 1. So you just copy this maximize z star, and at the same time lastly we need to write x comma y comma s1 comma s2 comma a1 greater than or equal to 0. This is also very important point. Then try to remember these. This is the now this is the LPP we need to solve. This is the LPP we need to solve by simplex method. What is the simplex method that we have already discussed in the previous classes? The same method is to be applicable here, but only the difference is we are making the original LPP to auxiliary LPP. So what is the difference means auxiliary will LPP having only 0 coefficients. So then go for the table 1. Okay, this is the constraints what we are having. So what are the equations we are having that we need to frame it in the table 1. So what is the table 1? We already noted the maximization z star equal to what are the coefficients? 0. The basic variables we are having x, y, s1, s2, a1. So correspondingly, the Cj values is 0, 0. For a1 only we are having -1. Is it? Then what are the constraints? What are the constraints we are having? 2x, 3y, 1 s1, and next 3x, 1y, what is it? Minus s2. So minus s2. What about the remaining terms? S1 is not be there. A1 is there. So A1 is 1. In this case, this is less than or equal to symbol. So no need of placing the S2 and A1. Then what are the basic variables means? In the previous class also we told that we have to give the preference to the slack variables apart from x and y. And at the same time now in the simplex method, we are having this slack variables. But in the two-phase simplex method, we are adding some artificial variables. So wherever the artificial variables are there, we need to give the preference to them only. So in the first phase, is there any slack artificial variables are there? No. In the first constraints, we are having only one variable, that is slack variable. In the second constraint, we are having slack variable and at the same time this artificial variable. In the both the case, we need to firstly give the preference to artificial variable, since we need to eliminate directly first. Then what are the coefficients? 0, minus 1. Then in the same method, find the what are the solutions? 6 and this is 3. So in the same way, you just ZJ. After that, we are having only 2 constraints. So no need of this row. And then finally, ZJ minus CJ. So ZJ, what is the ZJ value? Multiply with this 2 into 0 plus 3 into minus 1. What is the value? Minus 3. In the same way, 3 into 0 plus minus 1 into minus 1. Minus 1, 0, 1, minus 1. After that, ZJ minus CJ. So minus 3 minus 0, minus 3, minus 1 minus 0, 0, minus 1, 0, 1. This is the table 1. Then the same simplex method, what we have to do there? Most negative value. Most negative value means the negative sign which is having highest value. So minus 3, minus 1, 1. So these are all the positive values. You just neglect them. So try to be carefully seeing these. Most negative means negative with most highest value. So this is the most negative value, and making the key column. After that, Z ratio. How the ratio will be? XB by XJ. So key column, solution by key column. So 6 by 2 equal to 3 and 3 by 3 equal to 1. So next, we need to identify firstly most negative value in column and least positive value in, so least positive. So this is, so which one is the variable you are leaving? A1 is leaving, X is, so nextly we need to write the new table. Here what is the condition? A1, see here, A1 is leaving and X is entering. So here the key element is 3, where the key column and the key row are intersected. That is called the 3. And coming to the next table. So for coming to the next table, we need to do some operations. What are the operations? As there is no artificial variable in the problem, since our main intention is to introduction of artificial variable in the phase 1. Here in the phase 1, we need to introduce this artificial variable, and at the same time we need to eliminate the artificial variable. Then only our problem will be having a optimal solution. So here in the first table itself, the artificial variable was left out. So there is no need to fight for the artificial variable removed. Then coming to the second table. In the second table, objective function 0, 0, that is x, y, s1, s2, a1. A1 for this. Then here it is s1. Artificial variable was left out. That means a1 is leaving. X is entering. This is the no need of the table. Next, s1 variable is 0. X variable is 0. Then what is the thing? New x is equals to old a1. That means we are just replaced the a1. So a1 was removed and x was entered. So firstly, which one is the left out? Those row or those row is to be identified first. So old a1 minus what is something by key element or minus by key element. What are the values of old a1? What is the old a1? 310 310 minus 1 310 minus 1 1 3 by key element is 3. So for finding the 1 by 3 0 minus 1 by 3 1 by 3. So straightly write those values 1 1 by 3 0. Solution is after that we know that a simple hint is there. So whenever we are getting the 1 in the artificial variable or 1 in the variables of S1 or S2, we need to do a identity matrix procedure. So where the identity matrix are there, what are the basic variables we are having? There only the artificial variable identity matrix will be there. Here S1, A1. See here S1, 1, 0. What is the A1? 0, 1. If you see S2, 0, minus 1. No basic variable of S2 is there. So here also it is not the having identity matrix. So S1, A1. See here 1, 0, 0, 1. This is the identity matrix. So there also, now what is the new? S1, X. So S1 will be having what? 1, 0. What is the previously? S1 is having 1, 0 only. But A1, 0, 1. So 0, 1. Yes, from A1 to that will be transformed to X. So 0, 1. So to frame the 0 here, to frame the 0 in the this box, what is the solution we need to do? New S1 equal to old S1 minus 2. 2 you need to be 0. So 2 into new x. So like that, do the operations. What is the old? 2, 3, 1, 0, 0, and 6. If you see, no need to find out the third value also. 1, 2, 3. This value not be required. Since already we know that it is a 1. So for time consuming, we no need to calculate. This is also new x. New x is 1, 2, minus 2, minus 2, minus 2. What is the new values? 1 by 3, 1, minus 1 by 3, 1 by 3, 1 by 3, 0 is over, minus 1 by 3, 1 by 3, 1. So 0, this is how much? 7 by 3, this is already 1 is there. So 2 by 3, minus 2 by 3, and this is 4. Substitute all the values here. 7 by 3, 2 by 3, minus 2 by 3, this is 4. Then now it is the solution has come to there. Then again go for ZJ values. Why we are not getting these ZJ in the previous table? Means we need to find the optimal solution when Zj minus Cj for all the values should be greater than or equal to 0. This is already discussed in the simplex method. This is the equation we need to satisfy. But in the Zj minus Cj for all the values not be greater than or equal to 0. There is a two variables which are having less than or equal to 0. So then find the second one. Here also Zj minus Cj. Before that Zj. Or otherwise we can directly write it as, since we are having the coefficients as 0 here, anything with 0 multiplication, these are all the values will be 0 only. In the same time, Zj minus Cj. See here 0 minus 0. This will be the 1. Since 0 minus of minus 1, that is plus 1. So here, what is the condition? Zj minus Cj for all the values greater than or equal to 0. 0 is there, 0, 0, 0. Here also positive 1. So our optimal solution was found. For all the values, the greater than or equal to 0 was achieved, then the solution is optimal. So then the feasible solution is optimal, and there is no, see here, even though we are having this Zj minus Cj greater than or equal to 0, at the same time we need to see whether the table is having artificial variables or not. So even though if you satisfy Zj minus Cj is greater than 0, at the same time, if you are having the artificial variable in any of basic variable in this table, then our solution is not be a feasible. That means it is not framing the solution. The problem will be of discontinued. So if it satisfies this condition, but is there any artificial variable or there in the basic variables, see here, here or here, then the equations or the given problem will not form the solution. So we can end up there only. So here we need to satisfy these condition also. So in this case, there is no artificial variable. Then we may go for the second table or phase two. Okay. If we are having the artificial variable here, and at the same time the condition was satisfied, but the problem will be not having any feasible solution. So we need to stop there solving the problem and write the same condition. That is feasible solution is not be framed. So we are stopping the problem here. So in that case, no need to go for the phase two. Okay, that is the end of the problem. So that is the easy indication of a thing. Next, what is the table three? Table three is the for phase two. This is not phase one. So we have ended up the phase one there. We need to go for the phase two. This is phase two. So what does the phase two means? You just copy the previous table values as it is, except the objective function. Since the objective function was ended up there, we need to write the new objective function. New objective function, that is maximize z is equals to 4x plus 3y. That is the original one. But by eliminating, what are the eliminating? Artificial variables were eliminated. So no need to write it there. So finally we are getting 0 s1 plus 0 s2. This is the objective function. So write it there. This is 4, 3, 0, 0. That is x, y, s1, s2. No artificial variables need to be written there. Then what are the basic variables? What are the basic variables as it is in the uh, previous problem? I mean previous table. In the table 2, S1, X, 0, 1, 7 by 3, 1 by 3. As it is, these column is to be presented in the next table. So write it these values. These are already find there in the table 3. So, but the coefficient of basic variables will no need to copy that from the second table. We just present them from the current table or current object function, that is 4300. So this is 0, this is 4. This is not be required. No table is there. So then again Zj, what is the value? 4, 4 by 3. We are just multiplying 0 into 0 plus 4 into 1. So like that. Then what about the Zj minus Cj? This is 0. So in this case, we are having that so in this case we are having that Zj minus Cj. Then see Zj minus Cj is to be greater than or equal to 0. But here minus 5 by 3 is there, minus 4 by 3 is there. Then what is the value of most negative? Here denominators are same, but numerators are different. Which one is the highest? That will place the most negative value. So this is the highest value. Then by taking this column, same procedure, find the ratio, that is xp by xj. Then automatically we will find it is, these are the values. Then next one, most negative here, that means least positive. Most negative, least positive. So by eliminating least positive, S1 is leaving, Y is entering. So key element is 7 by. Then like that, if you go for the next table, we are just copying that same. Again, new y is equals to old S1 by key element, and next new x is equals to old x minus new y. This is a common, but which one is the thing we need to replace? That we will see. 4300, x is there, y is there, s1, s2. Here we are replacing y and x. xc, these are all already found from the previous table. So key element is 7 by 3. So divide the 7 by 3 or key element with the old values, then we will find the new element. So S1 is the old, S1 is the old, by key element we will frame the new y. So what is the old means? 0, 7 by 3, 1, 2 by 3, 4. So that you frame 0, 7 by 3 by 7 by 3, 1. Like that, if you frame these values, these are the final values. And according to that, old x is, here it is 1. So where we need to 1, 1 by 3, 0, minus 1 by 3, 1. Where we need to make the symbol of identity matrix as 0. That means S1 is having identity matrix 1, 0. It was replaced with Y. So in the Y column, we need to sanction 1, 0. So 1 by 3 used to be here. Previously 1 by 3 is there. So here we need to write it as 0. In the X, we are having 1 as usual. So 1 by 3 into new. New is 1. Old one is 1 by 3 minus 1 by 3 into 1. Simply we can do this. Like that, the same values also will be found. Then what are the coefficients? 3. This is 4 and multiply this column. This row is not to be required. 4, 3, same Zj minus Cj. This is the same procedure, but here Zj minus Cj is not getting the greater than or equal to symbol. So most negative round offing, same ratio. Here it is 0 minus 1. See here, this is the most negative in the column, but in the row least positive. Least positive means here 1 is there, but it is not a positive value, it is a negative value. So don't consider this one. We are having least positive value. So here only the positive value is 6. So we are just eliminating this and at the same time finding the key element. Here y is leaving, S2 is entered. So y is left, x2 was presented. So in the next table, same x, y, s1, s2, 4, 3, 0, 0. Here s2 was there, 4, 0. Then find this. Here find new s2 equal to old y by new s2 is equal to old y by key element. What is the key element presented here in the y? What is the key element? 2 by 3. S2 was presented here. 2 by 3. So like that, if you frame, the new row will be and according to that new x is equals to old x minus, here we will find 1, here we will find 0. So here we are getting the 0 means x0 in this case, that is minus 3 by 7. So plus 3 by 7 into new s2. If we follow these, we'll get it, the answers will be 21 by 4, 1 by, then do 4 Zj minus Cj, sorry, Zj, Cb into Xj. Again, 21, 2, 0, and Zj minus Cj, 4 minus 4, 0, 21 minus 3, 19, 2 minus 0, 2, 0 minus 0. So here we are getting the Zj minus Cj is greater than or equal to 0 for all the values. So here we found the solution. What is the solution means? What is the solution we are having? We can see from the directly here. Here there is no need to go for most negative. Is there? No. So that's why we don't need to go for, here the solution is 3. We don't need to go for ratio also. So if is there any most negative or negative values in the Zj minus Cj, then only we go for the ratio. Here no negative value are there, so we no need to go for the ratio finding also. So here S2 equal to 0, x equal to 4. Then substitute this in the equation. Here what about the y? No y will be there. Here the equations, the basic variables what we are finding, these are the solutions, and this equal to, so here y means may not be the value, let us consider it may be a 0. So substitute this in the original objective function. So optimal solution maximize, that is equals to 4x plus 3y. This is the actual. Or otherwise, if you see having 0s1 and 0s2 also, substitute this 4 into 4. The solution we are having. So this is not the solution. These are the solutions. 3. Sorry, x is equals to 3. S2 is equals to 6. These are the solutions. These are the coefficients. Then substitute this 4 into 3 plus 3 into y. Is there any value of y? No. Plus 0, S1 value is also no. Plus 0 into S2 value is 6. Substitute this 4 to 12 plus 0 plus 0 plus 0. So finally, maximize z is equals to 12. At x is equals to, this is the final equation we found here. So with that, we solved the two-phase simplex method. So two-phase simplex method is only applicable where the less than or equal to symbol and greater than or equal to symbol and equal to are presented. Only we are having less than or equal to symbol, we need to go for simplex method only. Apart from these, greater than or equal to or equal to are presented in the constraints, then we may go for the two-phase simplex method, or up to now graphical method we know, two-phase simplex method is also known. In the next class, we will see the big M method. So if you know the two-phase simplex method, it is easier to solve the big M method also. So that we will see in the next class.